Um, did you guys use the algebra tiles last year at all by any chance? Like the plastic, like the two color, like either squares or rectangles? Yeah, okay. Kind of, yes. All right. So what we're going to do today is just like a basic, way too much. All right. Well, I will say this, Mackenzie, with that comment, I will say this. I was very skeptical about the algebra tiles because I didn't quite understand them and the purpose for them. But I think once we get a little bit deeper into this lesson and we talk about factoring and something called an area model, that's not next week, it's a week after. To me, it'll make a little bit more sense. It made more sense using them then. So just bear with me on this one, okay? So today we're going to talk about using algebra tiles, and it's specifically talking about modeling algebraic expressions using those algebra tiles, okay? So I am recording this. I don't want you to take all sorts of time to like sketch these out, especially since you've used them. So just as a heads up, these slides are actually in the Schoology 6 folder, and with what you're going to do today, there's also a slide set up that has what each of the slides is and means. Hey, Sophia, I replied to your email, by the way. I don't know if you saw it or not. All right, so let's just get into it and just do a quick overview or reminder about what the slides are and they look like and how they match up and everything else. So if we were doing this in class and this was the first introduction to this, I would actually have you find one of each, trace it on your paper, and then we would label it and investigate it. But one of the things that I want to point out to you is they all have different colors based on their letters, first of all. And then the negative side of all of the tiles is red, right? So one thing to note is if you take a look at the X tile, if I moved this one tile, which it's going to be super slow for me, if I moved this one tile, the edges of that one tile match up specifically with the X tile. So we would say this is an X tile because it's one tall and X long. What is that X? We don't know. Okay, right? It's a variable. We're not quite sure what it is. And then also notice I've got this -1 here. This is X long. This smaller blue square here is X squared, because if I took the X squared tile and matched it up with its side, you would see that it's the same length. And then also, if I rotate it, super laggy because I'm using the recording thing. If I rotate it and match it up, it's the same height. And we know X times X is X squared. So I can do that with the Y tiles as well. Okay, the Y tile would match up. This, wowzers, the delay. The Y tiles would match up as well in terms of the width of the Y squared as well as the height. Okay, now notice the XY tiles. As a reminder, if I grabbed this X tile and dragged it up here, it's X wide and, oops, they're not in the front. Let's see. Bring that to the front. Bring the front. No, send it back. Order. There you go. So there's the X tile that I originally moved, and then here's the Y tile. So again, length times width for our tiles, and that's why that greenish one is called the XY tile. Now, we're going to talk about how do we use tiles to represent algebraic expressions, and then we're going to drag and drop tiles. One thing that I will tell you is dragging and dropping the tiles on here can kind of be finicky. So if you drag one like I just did and the X stays behind or it didn't do what you wanted it to, use that feature of Control Z, which means undoing, and it'll put it back to what you wanted. Okay, So what we're going to do today is we're going to talk about how can I use algebra tiles to show this algebraic expression of 3x plus 4. So we already know that this coefficient basically tells us I need 3 of the x tiles. Okay, so all you're going to do for your homework, actually, you're going to do something similar to this. You're going to do some work in a Google slide. When you move the slides, one of the things that we noticed is you don't want to click on it and then try and drag it. Sometimes it doesn't bring that X with it. So when you do grab it from the stack, if you just literally take it and drag it and drop it, okay? I didn't click it and then release. I was finding before when I was working with them, dragging it. Anyway, just grab it and go. Grab it and go, right? All right, let me put those two back because I need to show 3x and then plus 4. So here's my 3x's, right? 3 x's in a stack. And then for 4, I need 4 positives. So I'm going to do the same thing with these blue tiles. And I'm literally just dragging and dropping them onto the mat. That's it. So I'm going to use algebra tiles to show an algebraic expression. Now, I could get really crazy and crafty and do this. Tell me why this works. This also is 3x plus 4. Why does that work? Yeah, perfect. You got it. Thank you, Sam. Again, anytime you can match up the red and the non-red of any of the tiles. Right, Jesus, thank you. They make that 0 pair. CPM uses the term 0 pair. So same thing with what Sam and Jesus just said. Okay, so you can get creative. You can do extra tiles like that, or you can simply just do the 3x's and the 4's. The other thing that you're going to be asked to do is to take, whoops, I thought I clicked on it. There we go. Oops. Oh, I skipped this one. Sorry about that. All right, so the other thing that you're going to be asked to do is to simplify those tiles, and it goes back to what we just said on slide 4. We can simplify tiles and cancel out any 0 pairs by matching them up. So we can move tiles of the same kind. See, now it wouldn't let me move that one. There we go. We can move tiles of the same kind so that they are next to each other with as a like pair, and they can make a 0 pair. Kind of got a little attitude today. So I know that anytime I can match those up, this is going to cancel and make a 0 pair. This is going to make a 0 pair. This makes a 0 pair. Where else do you see a 0 pair on here? Or what else could I do to make a 0 pair? So what I'm going to do actually is let me grab my little pointer thing, and I'm going to drag this a little bit closer. I'm going to move these negative x's up. And I'm going to bring this down just so that they're next to each other, and I can show that that makes a 0 pair. What else can we make a 0 pair with, you guys? Yep, there's one. This makes a 0 pair. Is there anything else that we could like drag and drop and put next to each other to show that it'll make a 0 pair? Yep. Let me grab that X and bring it down here. Or not. Let me try again. There, we got it. And the X didn't come with. Hang on. You're being finicky today. Group. All right, let me try that again. So I'm going to move that X here. So be patient. Again, if it's not moving what you want it to, be patient. There's the zero pair. So then what we do is we take a look at what do we have remaining. Now, typically when we write algebraic expressions, oh, Emma just saw that as well. Oh, Jesus, yours too. When we write algebraic expressions, we typically try to write them with the exponent with the highest value and work our way down. So as we're looking at it, I see x squared. How many x squareds do we have? Yeah, we've got 2x squared. So then we would say 2x squared. You can do your squared one of two ways. You can either do it with that caret like that if you want, or you can do formatting superscript. And then it'll switch it. What else do we have? I would go to the other, I would do the x's then, right? These negative x's. How many negative x's do we have? Oh, I see yours, Kenzie. We can do that. We've got 2xy's, whoops, plus 2xy minus 2x. And what else do we have? Yep, we've got that 3, right? Positive 3. So if we had this pile of algebra tiles in front of us, this is what we, I didn't realize my caps lock was on. This is how we would write that answer. So simplify it, drag and drop, put tiles next to each other to cancel them out so that they make zero pairs. Simplify it, right? Simplifying algebraic expressions, it's like combining like terms. And then you tell me what's left over, okay? So simplifying the tiles, drag and drop for showing what the algebraic expression is. And then the same thing here. You are on your slides that you're going to have for homework. There's a stack of tiles here and you're literally just going to grab it and drag it. Grab it and drag it. Don't like hover over it. Don't just kind of wait. Just drag and drop. You'll see as you grab it that it'll highlight it. 3, 4, 5. It'll highlight the outline of it. And then once you have it, then you just drop it wherever you want. Now in this case, I chose to drop it in order, only because I'm a little concrete that way, right? But just be patient if it doesn't work for you right away. But I am finding that if you grab it more towards the corner, it'll work better for you. If you grab it in the middle, it's not going to work very well. Let's see, do I have enough yet? 1, 2, 3, 4, 5, 6, 7. So x squared, remember there's no coefficient. If there's no coefficient in front of the x term, it's just a 1. I put 5 negative x's, so minus 5x. And then I've got 1, 2, 3, 4, 5, 6, 7. Again, the tip with, oops, see, now my little 1 is gone here. The tip with moving the 1 squares is that, or any of the squares, is just grab it by the corner and drag and drop it where you need to. As soon as you somehow, for some reason, when you grab it in the middle, it's not going to drag and drop very well, okay? All right, so that's just a review and an overview. So on your notebook paper, if you were taking notes, or maybe in the chat, what's the difference between the red tiles and the non-red tiles? What is the difference between the red and non-red tiles? Sure, Sam. Do you want me to go back to one of those slides? The crazy one, that one? Okay. Good question. So that whole idea about finding those zero pairs that we did is actually doing the combining like terms. When you get here, if you look at our term, yes, this has an x and so does this one, but it's 2x squared and then the other one is regular 2x. And so remember, those aren't like terms. So in order to be like terms, they have to have the same base and exponent. I appreciate you asking that. I should have mentioned that back when we did that, talked about it. Okay, that's a good question. Yeah, Jesus, blue is positive, the red is the negative. For all of them, you guys, the non-red side is the negative. Okay, so your assignment is actually a little bit different today than what you're used to doing. Normally, I've got a worksheet or a Desmos for you to do. You're actually going to be given a copy of a slide deck very similar to this that we just did for our notes. You're going to complete the problems like we did. And actually, you're not even going to share it with me. I should have changed that. You're going to actually post your link to your slide deck on your DUR for lesson 6, and then you're going to grade yourself. So head on over into Schoology. You might need to refresh your screen. Stop my recording. You might need to refresh your screen so the slide deck or the folder shows